guys, welcome back to our daily LeetCode challenge series. And today's question is an easy one. Find the pivot integer given a positive integer n, find the pivot integer x such that the sum from 1 to x inclusive and from x to n inclusive is equal. Okay, so the question is like, suppose we are given n is equal to 8. So we have 1, 2, 3, 4, 5, 6, 7, 8. So now we need to find one element such that the sum from starting till that element and from end till that element is same. So if you see 6 is the answer here. How? If you do 1 plus 2 plus 3 plus 4 plus 6, that will give you 21. And if you do from end from that number till end, 6 plus 7 plus 8, that is also 21. We need to include this number in both, or other way around could be we can exclude this number from both. This is 15 and this is 15, like that. So this question seems to be like we can calculate our, the first thing that came to my mind, that we can calculate the prefix sum and make use of that. So I'll have one prefix sum array, and prefix sum array would look like 1 plus 2 3, 3 plus 3 6, 6 plus 4 10, 10 plus 5 15, 15 plus 6 21, 21 plus 7 28, 28 plus 8 36. This is my prefix sum array. So now what I can do is I can just loop over it, and suppose I'm going from 1, so the sum till here I can guess sum from beginning, sum from start is 1 when I'm on my first index 1, and sum from end is going to be my last one, that is 36 minus 1, that is the current, and we'll add this index also, this element also, right, which is going to be 36, because we need to include it, right? If I'll just do 36 minus 3, so this will give me the sum from 3 to 8, but I also want 2, like that. So for the next index, that is 2, sum from start is my 3, this one, and so the sum from end is 36 minus 2 minus 3 and plus that element on that index, that is 2, which is going to give me 35, right? So when we come to our 6 index, let's check that. Sum from start will become our 21, and sum from end will become our 36 minus 21, 36 minus 21 and plus that element 6, which is going to be 36 minus 15, which is going to be 21. So now sum from start is equal to sum from end. So we return this 6. This is how it works. So we'll just code it out quickly. So what I'll do is, see, there's one thing that I've calculated prefix sum array here, but in this case we can even skip creating this prefix sum array, because the sum from end, I mean the last sum, is always going to be n into n plus 1 and by 2, like that. So now if I want to calculate sum at index 4, prefix sum at index 4, what it will give me, 4 into 5 by 2, which is going to be 10, like that. So I need not keep track of this whole prefix array. I can just use this formula. So what I'll do is I'll just take first of all I'll return -1 in the worst case, and because -1 we have to return if it doesn't exist. So what we'll do is int last sum is going to be my n into n minus 1 by 2, like that. So now I'll loop over I is equal to 1, I is less than n, I plus plus. So I'll just take int sum from start, which is going to be my I into I plus 1 by 2, like that. And int sum from end. Sum from end, how we calculated? 36 minus sum from start plus that element. So that is last sum minus sum from start and plus that element I. So if sum from start is equal to our sum from end, we'll just return I, like that. Let's just check this. Okay, we've got something wrong. Let's just print it out once and let's see. Okay, this is n into n plus 1, not n minus 1. Yeah, works fine. Yes, works fine. And there's one more solution I found here which was really good, and that is this. So what they're doing here is they're just calculating the last sum, which is going to be 36, and then what they're doing, they're just calculating a square root, which is 6, and they're checking if it's a perfect square, this number, then the square root will be answer, else it is minus 1, and which in most of the cases, not of most of the cases, in all cases seems out to be true. Like in case of n equal to 8, the sum is 36 if we add all, and the square root is 6, and 6 is the answer. So this is a bit of good answer. And I was going through the editorial where I also found some good one, brute force. We'll skip it. You can just check it. They're just calculating from right also and left also every time. O square. This one is a good one. Yeah, we can see this. So what they're doing is they've taken one left value, that is R1, and right value is N. It's a two-pointer approach. So some left will keep track of our left value, some right will keep track of our right value. And if some left is less than some right, we'll add some left, increase left value, else this, and once they become equal, we'll just check it. Simple. And what else? Binary search. They've given a lot of solutions which I think are not that much valid here or required for us, because the range also which they have set is just up to 100. So we need not worry about that. And there's one thing that I just saw, left value plus 1 equal to right value minus 1 we are comparing. Let's just copy it out and let's just try to run it just to verify it. Um, okay, I got it why they're doing that. Yeah, so we need to check that sum left is equal to our sum right. Exactly, they need to be equal. And one more thing, that left value plus 1 should be equal to right value plus 1. Yeah, so how they're doing it is 1, 2, 3, 4, 5, 6, 7, 8. So sum left will, suppose we are on 6. So sum left will have 1 plus 2 plus 3 plus 4 plus 5, that is equal to 15. And sum right will have 7 plus 8, that is again 15. So we are comparing a sum left is equal to sum right, and also the left value, right now the left value is on 5 and right value is on 7. So these should be having a difference of just 1. Then only the middle one is going to be our pivot value, left value plus 1. So this is our left value L, and this is my right value R. So then only I can check like, Okay, now L and R just have one element in between and the sum on both sides is equal. So we'll just put L plus 1 is the answer this way. And what they're doing is starting the sum left is 1 and sum right is 8. So what they're doing it, we'll do 1 plus 2 and still it is smaller than 8. 1 plus 2 plus 3, it's still smaller. 1 plus 2 plus 3 plus 4, now this is 10. So now sum right is smaller. So we'll add 8 plus 7, which is 15. Now this one is smaller, now we'll go to 5. Now they have become equal. So this is the case. So that's it for this video guys. I hope you like it. Let me know in the comments. Thank you.